recording. I did not grade your homework assignments. Sorry, that may happen by tomorrow, but I have a couple of advising meetings this afternoon. So it may not happen by tomorrow. We will see. Otherwise, over this weekend for sure. But everything that got submitted was a PDF. So thank you for that. That is good and helpful. Yay. There are a couple that are a little weird, but I'll make them work. It's fine. And I will email them back to you. So if you're in just foundations, we've done that once. I figured out how to do it with annotating on a PDF, and it works much better than going to school and printing them out, etc. So that'll happen, just not sure if it'll be by tomorrow or not. Second thing, virtual office hours this afternoon. If you have questions, I have some advising appointments, but you can pop in and just hang out. I can put you in a breakout room or whatever if you have questions until I'm done with advising meetings. So whatever works there. That leads into classes for next semester, math classes for next semester. I mean, all classes for next semester are important, but especially math classes for next semester are important. Those are the important ones. So if you are not sure what you are taking next semester, feel free to shoot me an email. We can set up a Zoom meeting. We can do it over email. If I'm your advisor, that's great. I should be talking to you anyway. If I'm not your advisor, but you're trying to figure out math classes, that is fine. I am more than happy to talk about that too. Who is graduating, by the way? I'm just curious. Anybody? Bethany is graduating. Anybody else graduating at this point in time? No. Okay. All right. So therefore, the rest of you, I understand if it doesn't fit in your schedule, but it would be good if math classes fit in your schedule. So think about taking math classes. That would be helpful and beneficial. Those are my announcements, other than, I updated the schedule on Moodle and it is correct and set and ready to go. One of my goals for this afternoon is to set up the rest of the assignments so that you have that schedule, but you also have the due dates for assignments on Moodle, and that'll just kind of help you organize a little bit more. So, one other question from me. I am debating, if you don't want to fill it out, then I won't bother doing it, but I'm debating setting up a Google form, a totally anonymous survey, just to hear how online teaching is going, super short, like 3 questions. Is this something that you would spend time filling out? If you wouldn't, that's fine. I don't care. I won't bother setting it up then. But if you have feedback that you'd like to share anonymously, is this something that would be helpful? Maybe, yes, no. Abby has a question.
Is this just like for your class or
for my class?
Okay.
I mean, it could be if you wanted to comment on your other classes as well, but I can't do anything about those. So just for my class. Yes, no, yes, no, you would, you wouldn't, help me out. People are nodding at me, maybe. I would make it totally anonymous. I'm just looking to see how things are going. So super quick, 5 minutes. I'm getting enough yeses, maybes, potentiallys that I will, okay, I'll try to do that this afternoon and then fill out a link or send out a link. Any other procedural stuff before we get into section 4.5? Anybody, anything? Okay, section 4.5 then, whiteboard. Here we go. So, section 4.5. is periodic and piecewise continuous functions. Periodic and piecewise continuous functions. Periodic and piecewise continuous functions. So for the, I think we're about to 1,487th time, what we're trying to do is make it easier to take inverse Laplace transforms. That's what we're looking to do. That is our step number 3. We're going to get back to differential equations. We haven't solved a differential equation in a while, but we're going to get back to differential equations probably tomorrow, maybe not today. So today we've got some new functions that we are working with. So a new function that we are going to work with today is called the unit step function at t equals a. So we've got this new function that we are dealing with. It's called the unit step function at t equals a. There's two different notations for it. You can either do u sub a of t, that's one way of notating it, u sub a of t, or you can do u of t minus a. Both of those are notations that I would like for you to be comfortable with. Book uses both of them, so you should be relatively comfortable with both of those. All right, and I thought I closed my email, and I did not close my email. We're closing my email. Here we go. This is equal to this function. It is 0 if t is less than a, and it is 1 if t is bigger than or equal to a. Unit step function at t equals a. If we draw a picture of this, and a can be anything we want. I'm just going to draw it on the positive side here, but a can be anything we want. So it is 0 if we are to the left of a, 0 if we are to the left of a, and 1 if we are to the right of a. So that's this unit step function. The way to think about this in terms of differential equations is like you have a switch that gets turned on at time t equals a, and then you've got some external force acting upon an object with a constant magnitude, force, whatever you want to say, of 1. So remember way back in chapter 2, we talked about objects moving back and forth, and we said there were external forces acting on them. This is a constant external force of 1 kicking in at t equals a. So this is a super basic function. We're going to play with it and make it a little bit less basic, but we want to play with the very basic version first. Okay, Laplace transform of this. So this is in the front of your book. So the Laplace transform of this unit step function is e to the negative a times s over s for s bigger than, I think it's a. I think I have 0 in my notes, and I don't think that's what I want. S bigger than a, s bigger than 0. We'll go with s bigger than 0. Domain is not super important in this one. All right, so there's your Laplace transform. This function is boring by itself. It's really, 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 really boring by itself, because usually you don't have a force of 1 acting on an object. Usually you've got like a sine wave acting on an object or some other force. So generally speaking, what we do is combine this with other functions. So we can combining with other functions. Generally, that's what shows up in differential equations rather than just this function by itself. So two things. If we combine this with other functions, we can look at u sub a of t times f of t. So let's look at what happens if we combine this with another function. This is going to be 0 times f of t if t is less than a, and it's going to be 1 times f of t if t is greater than or equal to a. The 0 and the 1 and the piecewise part are coming from my unit step function. The unit step function has two pieces up here. So I have a 0 if t is less than a, and I have a 1 if t is bigger than or equal to a. That's where the 0 and the 1 are coming from the unit step function. And then I can totally simplify this. So this is going to be 0 if t is less than a, and little f of t if t is bigger than or equal to a. So basically, if you multiply by the unit step function, you just shift the function. That's what's going on. You shift the function, you get 0 to the left of a, and then you get the function itself to the right of a. Multiplying by the unit step function just shifts the function over to a. We can also do Laplace transforms in combining with other functions. So here's our theorem for the day. So Laplace transforms. 2 halves, because we always have a forward direction and a backward direction. So first of all, the Laplace transform of u sub a of t times f of t minus a is e to the negative a times s times capital F of s. That's the forward direction. If you have this combination of two functions with the unit step function and you take the Laplace transform, then you are going to get e to the negative a times s times f of s. We're gonna have to be a little careful, and I'll show you how this works when we do some examples. We've got this f of t minus a inside of here, so we're gonna have to be a little careful with that. And it just requires a little bit of algebra, a little bit of playing around to deal with that. That's the forward direction. And then we can do the backwards direction with inverse transforms, right? So the inverse Laplace transform of e to the negative as times capital F of s is that unit step function times f of t minus a. Just taking that first equation and doing inverse transforms of both sides. We should be good at this by now. We should be good at realizing that theorems for Laplace transforms always come in pairs. They come in pairs because we can do a forward direction and a backward direction. Okay, let's start out with a really easy example because this doesn't make sense to you right now. We need to do an example. We're gonna start out with a really easy example and then we'll make them slightly more difficult. All right, so if we have, for example, capital X of s is e to the negative 3s over s squared. And I want to find little x of t. So again, we're jumping into the middle of the problem. We've done step one with the differential equation. We've taken the Laplace transform of both sides. We've done step two and solved for capital X of s. Now we're ready for step three. So here's what we got. My a value in this case is negative 3. I'm hoping that you can see why my a value is negative 3 if we've got e to the negative as. And my other function that I am working with, capital F of s, is 1 over s squared. That's the rest of the stuff without the e. So the rest of the stuff without the e is the 1 over s squared. Okay, questions up to that point? Do a virtual hand raise if you had a question. Questions up to that point? Zach, I can see you. I can't see anybody else, but I can see you. What do you got?
Wouldn't a be 3?
Would a be 3? Yes, in fact, it would. Let's try that instead. Sorry, a is equal to positive 3. Thank you, because we have e to the negative as. So yes, I want a equals positive 3 instead of negative 3. Thank you. Okay, so if my capital F of s is 1 over s squared, front of your book, please, go ahead and find your little f of t. If you have an inverse transform, what's my little f of t? This should be right there, easy to find, totally nice and obvious, easy one that I'm starting you out with. Little f of t equals t. I think we're good with that. That part's easy. All right, so therefore my inverse transform, little x of t, is u sub 3 of t times f of t minus 3. I'm going to rewrite that. I'm probably not going to write this step anymore in the future, but we'll write it for the first time here. That's exactly what my theorem up here says. So this is going to be u sub 3 of t times t minus 3. My f of t is t. So f of t minus 3, if you plug in, is just t minus 3, right? And then remember what this does, this shifts. So this is 0 if t is less than 3, and t minus 3 if t is bigger than or equal to 3. I'm probably going to jump to this last step here with the piecewise part in the next example. When you are doing your homework, if you want to jump to that last step, that is totally and completely fine. You can absolutely jump there. All right, questions on that one before we do the next example? Anything there? Anybody, anything? Okay, next one then. Let's do this one. Here we go. For example, more complicated. We have capital X of s is s times e to the negative s over s squared plus pi squared. And I want to find little x of t. capital X of S is S e to the negative S over S squared plus pi squared, and I want to find little x of t. So my A is equal to positive 1, in this case, not negative 1, but positive 1. My A is equal to positive 1. And my capital F of S is S over S squared plus pi squared. All right, so for the 1495th time, front of your book, what's your little f of t in this case? Front of your book, go find your little f of t for me, please. Ends up being cosine of pi times t. Do we like cosine of pi times t? That's good. All right. So now I'm going to jump to my final answer. If you're not comfortable with this jump, go back to the previous slide. So we are going to say little x of t is then 0 if t is less than 1, and cosine of pi times t minus 1 if t is bigger than or equal to 1. So we've zeroed out. We've got a 0 if t is less than 1, and that 1 comes because, again, my a is equal to 1 in this case, and cosine of pi times t minus 1 if t is bigger than or equal to 1. So that's my inverse transform in this case. Okay, you're still writing, so I'm going to stop sharing my screen in just a sec, but I'm going to let you finish writing. I'll stop sharing my screen, see if we have questions, and then we'll kind of do some forward ones. The forward ones are a little harder in this case. Okay, anything on questions at that point in time? Anybody for questions? Going backwards, identifying your value of A, figuring out your capital F of S. We're good to go? Give me a thumbs up. Going forward is okay at this point in time? Yes, good, yes, okay. Let's go backwards then. So let's try a backwards one. How about this one? For example, let us do g of t, and I'm calling it g for a reason. G of t is 0 if t is less than 3, and it's going to be t squared if t is bigger than or equal to t, and I want to find capital G of S. So G of t is 0 if t is less than 3. It is t squared if t is bigger than or equal to 3. We want to find capital G of S. A value first. Hold up fingers for me. You should be able to do this with fingers. What is your value of A in this case? Your value of A in this case is A equals 3. I'm seeing lots of 3s. Good. A equals 3. Okay, so what I need, and this is where it gets a little confusing, I need G of t to look like 0 if t is less than 3. 0 if t is less than 3. And I need it to look like f of t minus 3 if t is bigger than or equal to 3. That's what my function has to look like. I gotta have an f of t minus 3 in here. That's what our functions looked like on the previous slide. That's what it has to look like now. So in other words, what I need is f of t minus 3 to be t squared. That's what has to happen. I need my f of t minus 3 to be t squared. So in other words, when I take my function f, when I put in t minus 3, I need to get out t squared. So this is where you kind of got to think backwards a little bit. You want to choose f of t to equal t plus 3 quantity squared. Think about why that works. We're going backwards. If you take your t minus 3 and plug it in here for t, you are going to get your t squared out. That's what you want. That's what you're looking for. So you kind of add and subtract interchangeably. You go backwards. And then I'm going to need to square this out. So this is t squared plus 6t plus 9. If I do some FOIL, square that out, t squared plus 6t plus 9. FOIL. So, front of your book, what's capital F of S in this case? Front of your book, we've got our little f of t. What's capital F of S in this case? What do you have? What do you got? If I have t squared plus 6t plus 9, front of your book, capital F of S. Go find capital F of S. I'm going to write it out while you are looking. Two over s cubed plus 6 over s squared plus 9 over s. 2 over s cubed plus 6 over s squared plus 9 over s. Okay, so going back, I'm going to back up a couple of slides, going back to our theorem. What I need to do is multiply by e to the negative a times s. So therefore, my answer in this case, capital G of s, because that's the function I was working with originally, e to the negative 3 times s, 2 over s cubed plus 6 over s squared plus 9 over s. And that's the answer that I am looking for. Oops, didn't quite box that answer so well. E to the negative 3s, 2 over s cubed plus 6 over s squared plus 9 over s. By far, the tricky part in this is figuring out your little f of t, where you got to kind of undo it, reverse do it, figure out what your little f of t is going to be so that you get your function in the correct form. All right, let me make you big. Let me see if I have anything for questions at this point in time. Questions at this point in time? Anybody, anything? Daniel.
Yeah, I'm just so confused. Okay, for the going backwards part, when you do like f of t minus 3 equals t squared, like how we got to choose, because like I see how that's the reverse kind of, but well, I guess I don't see how that like cancels with the minus 3.
So see what, look what happens. Let's actually write it out, and we're going to look at what happens when we write it out. So what happens when we do f of t minus 3? That is going to end up being t minus 3 plus 3 quantity squared, right?
Oh, okay.
And then you're going to get, yep, t minus 3 plus 3 quantity squared. So you just get t squared, which is what you wanted.
Right. Yeah.
Okay, I feel like I didn't
yeah,
answer your question.
I was just thinking like it's supposed to be on the inside, but
Yeah.
I guess that makes more sense.
Yes.
Like I was like, yeah, okay, thanks.
That's the tricky part, by far. This is definitely the tricky part of the problem, coming up with your little f of t and making sure you subtracted or added or whatever you were supposed to be doing. That's totally the tricky part.
Thanks, yeah.
Okay, other questions? I am going to work on being able to see all of you again. Other questions at this point in time? Anybody, anything, other questions now? Okay, I want to have you do another one, but I want to put you in breakout rooms to do this one. So let me pop up my next example, and then I'm going to throw you into breakout rooms and have you guys try this one. For example, let's say that little g of t is equal to 0 if t is less than negative 4, and it is going to be t squared plus 6t if t is greater than or equal to negative 4. 0 if t is less than negative 4, t squared plus 6t if t is greater than or equal to negative 4. And I want to find capital G of s. 0 if t is less than negative 4, t squared plus 6t if t is greater than or equal to negative 4. I think everybody's got that copy down because I've repeated it like 8 times. Hopefully, maybe. Does everybody have that one written down? Good. Okay, let's do random breakout rooms here. And you are going to get an invitation. Go ahead to your breakout room. Don't just work on this individually. Talk about it with other people. Please and thank you. Go. You should have gotten an invite to go in breakout rooms. Now you should have. There you go.